Hi, this is Mike Shigalone with Math3DU, and today we're going to be doing some additional problems involving systems of equations and their graphical solutions. Okay, starting with problem number 1, this wants us to affirm that the ordered pair x equals 4, y equals negative 1 is a solution to the system of equations x minus 4y equals 8 and 2x plus 2y equals 6. In order to do this, we're just going to plug in x equals 4 every place we see an x, and y equals negative 1 every place we see a y. Using the first equation, we get 4 minus 4 times negative 1, and this should equals 8. Simplifying, we get 4 plus 4, and this does in fact equal 8. So the ordered pair x equals 4, y equals negative 1 is a solution to this first equation we just found out. Now we move on to the second equation. So we plug in x equals 4, and we plug in y equals negative 1, and it should be equal to 6. Simplifying this, we get 8 minus 2, and this does equal 6. So 4 negative 1 is also a solution to the second equation. So we just found out that the ordered pair x equals 4, y equals negative 1 is a solution to this system of equations. Moving on to problem number 2. This is similar to problem number 1, except we are finding if the ordered pair x equals 2, y equals negative 1 is a solution to the system x minus 4y equals 6, 2x minus 8y equals 12. And just like before, we're going to plug in x equals 2 for x, y equals negative 1 for y. So we get 2 minus 4 times negative 1, and see if it equals 6. Simplifying this, we get 2 plus 4, which is equal to 6. So our first equation checks out. Now we test it with our second equation. We get 2 times 2 minus 8 times negative 1, and this should equal 12. Simplifying once again, we get 4 plus 8, and we see that that equals 12. So we know our solution is a solution to both equations. Okay, now looking at problem number 3, this wants us to find the solution to the system of equations y equals negative x plus 3 and y equals x minus 1. And if you notice, these equations are already in slope-intercept form, so that'll make it easier for us to graph. Starting with the first equation, we're going to start by graphing the y-intercept, which is 0 plus 3. So we graph the point 0 and go up 3. We get a point there. And we see that it has a slope of negative 1. So we go down 1 over to the right 1. That's our next point. So our line looks like this. Using the second equation, y equals x minus 1, we start with the slope-intercept, 0, negative 1. And we see that it has a positive slope of 1. So we go up. And we see that our solution is right here at x equals 2, y equals 1. So the ordered pair 2, 1 satisfies both equations. Okay, now problem number 4. Once again, it wants us to find the solution of the system of equations y equals x minus 2 and y equals x plus 2. And if you notice right away, these equations have the same slope of 1, but different y-intercepts. So let's see how that affects our solution. Starting with the first equation, we graph the y-intercept 0 minus 2. and it has a slope of 1. So we go up 1 and over 1 from that point. Now our second equation has a y-intercept of 0 plus 2. So we make a point there, and we go up 1 and over 1 from that point. And if you can tell, these lines will never intersect. They're parallel. So our system of equations has no solution. Okay, now problem number 5, once again, wants us to find the solution to the system of equations y equals x plus 2 and y equals x plus 2. If you notice, these are the same exact equation. So if we graph our first equation, we get a line that passes through the point 0, 2 and has a slope of 1. If we look at our second equation, we get the same line that passes through 0, 2 and has the same slope of 1. These lines have infinitely many solutions, so we say that this system is linearly dependent. Okay, problem number 6 once again wants us to find the solution to the system of equations 4y minus 2x equals 6 and 6y minus 3x equals 9. We can see that these are not in slope-intercept form, so right away I'm going to convert them. Starting from the first equation, I get 4y equals 6 plus 2x. And now dividing by 4, we get y equals 1/2 x plus 3/2. So using this equation, we start with the point 0, 3/2, which is right here, and it has a slope of 1/2. So we go up 1 from this point and over 2. Now our second equation, simplifying this, we get 6y equals 3x plus 9. Dividing by 6, we reduce this to y equals 1/2 x plus 3/2. And we can see that these are the same exact equations. Once again, this system of equations contains infinitely many solutions. This system is linearly dependent. If we look at problem number 7, this wants us to once again find the solution to the system of equations 4y minus 2x equals 6 and 6y minus 3x equals 12. And just like before, we have to convert to slope-intercept form. So starting from the first equation, we get 4y equals 2x plus 6. Dividing by 4, we get y equals 1/2 x plus 3/2. Looking at our second equation, we get 6y equals 3x plus 12. And if we divide by 6, we reduce this equation to y equals 1/2 x plus 2. So if we graph this first equation, we're going to start with the point 0, 3/2, and our slope is 1/2, so we go up 1 over 2. And we get this line for our first equation. Now our second equation, we start at the point 0, 2, and it has the same slope as our first line, 1/2. So we go up 1 over 2. And we can see that these lines are parallel, so they have no solution. Okay, for our final problem, once again, we're going to find the solution to the system 2y plus 3x minus 6 equals 0 and minus 2x plus 4 equals 0. Once again, I'm going to put these in slope-intercept form. So if we start with our first equation, 2y plus 3x minus 6 equals 0, and we subtract a 3x from both sides, and we also add a 6 to both sides. We end up with 2y equals negative 3x plus 6. And now dividing by 2, we end up with y equals negative 3 halves x plus 3. Now to graph this, I'm going to start with the y-intercept, 0, 3, and it has a slope of negative 3 halves. So I'm going to go down 3 and over 2. And our first equation looks like this. Now our second equation, y minus 2x plus 4 equals 0. We start with adding 2x to both sides and subtracting a 4 from both sides. So our equation then becomes y equals 2x minus 4. And to graph this, I'm going to start at the y-intercept, 0, negative 4. And this equation has a slope of 2. So we go up 2 and over 1. And we construct our second line, which passes through the point 0, 2. So we can see that 0, 2 is the solution to this system of equations. Well, that's all the additional practice for this topic. Make sure to subscribe for our future lessons. This is Mike with Math for EDU. Thanks for learning with us.